A projectile is launched on level ground at the peak of its trajectory. It is 7.5 meters high. It lands 10 meters from where it was launched. At what angle was the projectile launched? So the maximum height in this case 7.5, and also the horizontal displacement, which is the horizontal range, is 10 meters. Now y is equal to 7.5 according to the question, and x, which is the horizontal displacement, is nothing but 10 meters. G is always equal to 9.8 meters per second squared. What we're looking for is theta. So let's see what we're going to do about it. Now here there is no mention of time, so meaning for the vertical motion, calculating the velocity, we use the equation. First I have to draw this showing the trajectory. Okay, so we have that on the horizontal ground to 10. So we'll draw this line representing the initial speed at which the projectile is traveling at, and also I will draw the trajectory for the same projectile, which moves like this. Then the angle of projection here is the one we're looking for. Okay, so we'll use the equation of motion that we looked at under kinematics, which is v squared u squared plus 2as. Okay, maximum height here is 7.5. At this point v is equals to 0. That's what you know. At the peak v is equals to 0. So for the vertical motion, we have that the final component of velocity squared will be equals to the initial component of velocity squared minus 2gh. Okay, now here we have 10 meters and there we have 7.5. So coming back to our equation, the final velocity is 0 at the peak or at the highest point reached. So I get a 0 there. Then this will be equals to the initial component in the y-axis squared minus 2gh. So we're going to move the negative 2gh to the left, making it to be positive. So it will be 2gh equal to the initial squared. So we can switch positions like this. Then being that this is squared, we're going to square root both sides, giving us our initial component to be equal to the square root of 2gh. Okay, now we can calculate the time taken to reach the peak, and that is by using the formula v is equals to u plus 80. So it will be u plus 80. We'll have that final velocity here equals to the initial, then minus gt. Like what we did, the final at the peak is 0, so we'll have 0 here. So you need to recall that final velocity at the highest point reached is 0, like it is stated there on this parabolic trajectory. So we replace there with the 0 in the equation. Negative gt will be moved to the left, making it to be positive gt equals to the initial. Then we divide both sides by g, leaving us with t equal to the initial component over g. Now the initial component is something that we've already derived from what we've written above. Thus our time So our initial is equals to the root of 2gh. So that's what we're going to replace there on the numerator. So t will now be expressed as the square root of 2gh divided by g. Now what we'll do is we're going to simply replace the values to find the time taken to reach the highest point. So it will be 2 times 9.8 times 7.5, that is under the root. Then everything to be divided with 9.8. Now we find out that upon doing everything, our t will be equals to 1.237 seconds. Now our main aim is to find the angle of projection. So we really need to find the total time taken. So this time we've obtained is the time taken to reach highest point. So to find the time taken for the whole trajectory, which is the time of flight, we need to note that that time of flight is always twice the time taken to reach greatest point. That time of flight will be we say 2 times of what we just obtained, which is 2 times of 1.23. And for this calculation, our answer is equals to 2.474 seconds. Okay, that's what we have for the time of flight. Now let us consider the motion of this projectile in the horizontal axis. That's why we get the displacement there, which is also the horizontal range, which is x equal to the initial velocity component times the time of flight. As we know, in this axis the velocity is constant, so phi and initial are the same. So I divide both sides by t to make the initial velocity subject of the formula. Thus we have x over t. Then we now substitute the values for x. X is 10 and t is 2.474, giving us 4.04 as our answer for the initial velocity in the x-axis. This is measured in meters per second. Also, we need to obtain the vertical initial velocity, which is that we have under the root. Yeah, so this one is 12.12 upon doing calculations there. Now, borrowing concepts from trigonometry, we have that tan theta wants to find the value of the angle. So what we have is that tan theta is equal to uy over ux. Now meaning that the angle theta will be equal to tan inverse of what we have on the other side. We'll put it in parentheses like that. So meaning that our theta will be equal to tan inverse of 12.12 divided by 4.04. Upon doing our calculations, we have that angle theta, the one we've been looking for, is 71.56, and